So the experiment that we're going to be doing today is the 9-volt firecracker. So what you're going to need is a glass jar or a beaker, a metal tray, a 9-volt battery, and a piece of steel wool. So before you start this experiment, it may be helpful to explain current, voltage, and resistance before you start. So current is the rate of charges flowing through a circuit and describes how many charges pass a certain point per second. Voltage is a little bit hard to describe, but basically it is the difference in potential energy of the electrons in a circuit between 2 points on a circuit. So it describes how badly electrons want to get to the other end of the circuit. Resistance is basically the material's tendency to resist the flow of charge as the charges hit and pull other atoms and particles in the wire, which typically heats up the wire. So resistance is controlled by a few factors, such as the material of the wire, length, temperature, and thickness. So for example, the thicker and shorter a wire is, the less resistance the electricity will experience as it crosses the wire. So what we're going to be doing is we're just going to fluff up the steel wool so it experiences as much contact with the air as possible. And then once we touch the 9-volt battery to the steel wool, it should create a fire within the steel wool. And if it gets to be too much, all you got to do is place the jar over the steel wool. So as the 9-volt battery touches the steel wool, it creates a quick circuit from the positive to the negative end. But as the current goes through the thin steel wires, it creates a lot of resistance and actually burns. So since this is a very thin and long wire, the electrical current will experience more resistance. So I'm just going to touch the end of the battery to the steel wool. And even though I took off the battery and there's no longer a circuit and thus no electricity flowing, the fire keeps burning the steel wool.